So today we get to learn about what makes a good sample and a bad sample. Remember, if we were trying to survey like Hayes High School, it would be very difficult to survey all 1,000 some odd students because there's just so many of them, so you get like a sample of them. But what makes a good sample and a bad sample? Today we'll learn about two bad samples called a convenient sample is one of them. A convenient sample is right in the word. It's really convenient to do. It consists of individuals from the population who are easy to reach. Real easy to reach. Easy way to say that is imagine I made you just go survey 10 random people that you wanted to, just go survey 10 people about something, and if you went right over to that classroom right over there and the first 10 people you found, like that was pretty convenient, right? It might not be the best sample ever. Just like if I said pick any 5 words from this list right here, and I picked 1, 2, 3, 4, 5. Wasn't that convenient? You know, it's just the first 5 that I came across in that situation. So that might not represent all the words the best in this bad boy. So a voluntary response sample is a little weirder. You know, I think once we dive into our examples, we'll understand it. But those are people who chose to be in the sample by responding. They chose to be in it. So like if I asked, you know, it's like I just sent a survey to all Hayes High students that said, hey, please vote on like prom king, prom queen, you know, it's the people who wanted to do it, right? It's like, well, I don't care, so I'm not going to vote kind of stuff. So it's a voluntary response sample. Then a bias. I think you've heard the word bias before. Have we heard bias? It's like there's something wrong with this. It's like, hey, that wasn't right. There's some sort of bias on that. So it's a design of a statistical study that shows bias if it's very likely to either underestimate or overestimate the value you want to know. Like there's a bias in that. If it gives a number that either underestimates or overestimates. And then finally, the thing of the day I'll bet you figure out is like how to take a random sample. We'll learn about that all chapter long, but what is a random sample? It consists of individuals from the population who are selected by chance. Like that's where we used the random number generator a second ago. Like you didn't pick those. It's just random chance that those numbers came up. That is a random number generator, so a random sample. So let's dive in, man. It's pretty cool stuff when you start thinking about these. The first 3 is bad samples, called convenient samples. So kind of some weird situations here too. Suppose we want to know how much time students spend at a large high school doing homework last week. How long did you do homework for is what the question is. And here's where they went to survey and find some people for a sample. They went to the school library and asked the first 30 students they saw, how much time did you spend doing homework? Are you cool that that is convenient, right? They just went somewhere and found 30 people. That was pretty convenient for them. What could be a bias in that? What is the question they're asking? How long did you do homework? Who did they ask? People where? We're not trying to like be mean about any of this stuff, but let me ask you a serious question. Who's more likely to hang out in the library? Kids who do a lot of homework or kids who don't do a lot of homework? They probably do their homework. They probably like to read. They probably do all this like I like books kind of stuff, right? So do you think that is fair to survey only people who very likely like to read and do homework about how long they spent doing homework? Do you think that would give a good representation of the entire school? What do you think? Probably not, right? Because what do you think? Don't those people probably do more homework than the average student in that situation? So explain how this is a convenient sample. You can make this shorter if you want. You don't have to write all of that down. But it's possible that students who are at the library are there to do homework and doing more homework than a typical student. You can summarize that as short as you need to. Like people in the library are probably doing more homework. But what a weird question, you know? It's like, okay, how much homework time on average? If we only like went and asked people who do their homework all the time, that's going to give us way too high of an estimate. What would be better? How could we find a better way to generalize it? Guess what kind of sample we need? A random sample of all the kids in the high school, right? We need to just randomly select students at a high school. So like It's not easy to do, but you'd have to have a list of, if there's 1,000 kids at this school, like all 1,000 of them, and number them, and like let a random number generator select 30 of them. That would be a fair job of picking 30 people to represent the school than just picking a bunch of people who are in the library. That's called a convenience sample. So randomly selected. Here's the second one. A school nurse wants to know, like, if the students at his school are overweight on average. Again, not trying to pick on anybody or anything like that, but it's a real question. So here's what that school nurse did. After school one day, they walked to the gym. Across the hall from his office. You see, that's pretty convenient, just right across the hall, right? And I'm going to the gym, and I'm going to select the first 20 students I see to see if they're, like, how much they weigh, if they're overweight, right? Do you think that those 20 students that were selected by this nurse represent the entire school fairly, or is there a bias in that situation? There's probably a bias, right? Because why? Where were they at? Even though they picked the first 20, they saw where were they at? In the gym. Who's hanging out in the gym? More likely, students who are fit or not so fit. Again, we're not trying to profile anybody, you know, we're not trying to be mean about it, but would you believe more athletes hang out in the gym than non-athletes? Are you with me on that? So they're usually in better shape. It doesn't mean some of them can't be overweight. Are you with me on that? But it's just one of those things. So there is a bias in that because students in the gym are likely to be doing physical activity or maybe don't weigh as much. You can word it however you want, but I mean, some of the kids who are just quote-unquote out of shape probably don't hang out in the gym on their own. Unless the school forces them to, like sometimes, like at the middle school, they force you to sit in the gym in the mornings, you know, kind of stuff. But, like, you see what I'm saying? I hate to bring, like, weird stuff like weight and all those things in there. We just got to understand it's just a survey. How can we generalize, like, if kids are overweight? Guess what kind of sample we would need to find of all these kids at the school? A starts with an R, a random sample. We need to do a random sample of all the students at the school if they were randomly selected. Again, you just probably number them all and just say, hey, I need to go find student number 18, student number 431, student number this. This randomly selected is kind of the moral of the story. And randomly selected from what? Whatever you were trying to study. And this wasn't just like the weight of the students at the school in that case. So one more convenience sample. I bet this one makes pretty good sense now that you've seen a couple of them. A farmer brings a juice company many crates of oranges each week. So this guy was like growing oranges and selling oranges. The company inspector looks at 10 oranges from the top of the crate before deciding whether to buy all the oranges or not. Why would that be biased? Where did they find the oranges in the crate? From the top. Isn't that convenient just to look at the top 10? Why could that be biased? What if you were the farmer? What might be true about the oranges on top compared to the rest of the oranges? What if the farmer had some bad oranges in there? What would he probably maybe try to do with them? Like hide them a little bit on the bottom? Are you with me? So like, unless this guy who's buying the oranges goes through the whole crate and kind of looks at, not necessarily all of them, but looks like some top, some middle, some this, there's a bias in that. You can't just look at the ones on the top, you know, so please don't write all that down. But the oranges on the top are probably not as damaged as the oranges on the bottom. You know, the oranges on the top are probably not as damaged. And then what I also put, again, you can write this down if you want or not. I like rather just talking about them instead of writing so many notes. But it's just like, it's very possible the farmer specifically picked the best oranges and put them on top. So it looks like a really good crate. It's like, ooh, look at that. You know, that's a bias. So what should the guy buying it do to realize the quality of the orange is best? He's got to look and find some oranges at, starts with an R, random, right? He's got to randomly select some oranges in the crate. It probably wouldn't go as so crazy as numbering all the oranges and then picking out like orange number 1 and orange number 17, and orange, but it's just like randomly selects different areas to look through and go, these look pretty good. Because there could be, you know, like 50, 70 some oranges in this crate. It's like, let me just look at a few of them from here, there, and what else. Those are called convenient samples though, right? It was really convenient to look at. These were conveniently on top. The nurse just went across the hall and found 30 kids they wanted. These other people just went to the library and found the first 30 kids. That was convenience. Here's the ones I think are cool, is the voluntary response samples. These are people who chose to be in the survey. So I know this is very out of date, but long, long time ago when the newspaper was the driving force for media, you know, be like TV before social media, when the newspaper, this lady called Ann Landers used to like write this article. It was a national publication. Every newspaper ran it once a week, her thoughts. She asked readers of hers for a long-running advice column, if you had to do it over again, would you have children? That was just the question that Ann Landers wrote. Hey man, if you could do your life all over again, would you have children? Here's what she got back from that survey. Over 10,000 or almost 10,000 responses, and 70% of those responses said, no way, wouldn't do it. Why is that biased? Well, was everyone forced to reply, or did they choose to reply to this survey? What do you think? They chose. Guess why they chose? Because they had a strong opinion. Are you with me? They had a strong opinion. So it's like most of the people who replied said no because they probably were like, If someone was like, oh yes, I really love my kids, they probably replied also. But if someone didn't care, it's like, I don't care about this question. Would you believe they probably didn't reply, right? All the people who were, doesn't matter, didn't reply. So that's because about people who feel strongly about it. People with a strong opinion, and I put on this one, especially no, are more likely to respond. People with a strong opinion, especially no, are more likely to respond. People with a strong opinion are more likely to respond. Easy one for you also. We sent a survey out to all Hays High students. The question was, should juniors get out of high school at 2:30 every day while everyone else stays till 3:15? I bet you'd get some really strong responses. Would you agree with that? What do you think almost all the juniors would say to that? Yes or no? Yes. What do you think everybody else would say? No freaking way, because they have a strong, and some people don't care, right? You know, maybe a freshman doesn't care, so whatever, I don't care. But I bet you, if there's 250 kids in the junior class, you would get over 220 responses of yes. You know what I mean? It's like, you bet. Because that's a voluntary response. And then the last one of these, the athletic department of El Dorado Community College wants to learn more about the number of push-ups a student can perform. To find their sample, they did this. They set up a booth, and they had a sign that says, push-up contest today, free to enter. Who's signing up for that? People that can do push-ups. Would you agree? If you suck at push-ups, you're like, I don't want to be in this, right? You know, it's like the only people, I shouldn't say the only, the most likely people to sign up for this contest are people who are really good at push-ups. So that's because fit students are more likely to respond. That would totally skew the results of like, how fit are kids at this El Dorado Community College? Because you picked on some of the strongest or fittest people because they're good at doing push-ups. When can we generalize a finding about how many push-ups they can do? Guess what we should do at this school? Take a random sample. If you randomly selected all kinds of students and kind of forced them to do push-ups, which is cruel, you know, but it's like, how many push-ups can you do? I don't want to do any. Too bad, do them. Randomly select. So 2 things today we talked about was the convenient sample, because they were easy to find, and the voluntary response, which usually isn't good because people who like are strong in one direction are probably more likely to answer that. The last part is both of them had to deal with a personal choice, right? Both of them had to do with a personal choice. A convenient sample, you actually chose to just keep it easy on yourself. And in a voluntary response sample, those people totally chose to answer the question because they felt strongly. But the best way to avoid this problem is to let chance choose the sample. If you wrote the word randomness, that is also fine. Yes? that brings us to our last question. We're going to do an experiment about what's better, long putter or short putter. How should we decide who gets what putter? Should I let you choose? Or should we do it randomly? We should probably do it randomly. Because if you chose, especially if you were good at golf and you're really good with the short putter, it's like, I choose that one. Well, that's not fair, you know. It's like you have to be randomly assigned. Cool. So we will do a little homework, maybe. Should be a pretty short one again today. Let me know if you have any questions. Have a good one.